Alright, today we're going to start taking a look at geometric sequences since we just finished arithmetic. Now, a geometric sequence is a sequence whose term increase or decrease by a common ratio. In other words, we're going to multiply or divide, and we call that common ratio R. So let's take a look at an example here. Take a look at this pattern here. 2, 4, 8, 16, 32. We keep multiplying by 2, not adding this time. Every one of these is being multiplied by 2. So they have a common ratio. So R is 2 in this case. Now, the reason why we call it a ratio is because it's going to, normally how we get it, it's the new over the old. For example, if I look at the 4 over its previous one, 2, I can look at 32 over its previous one, 16, and they both reduce to 2. And that's why we call it a ratio instead. So, let's take a look at this one. How will we get the common ratio? It's 1 1/3, 1/9, 1/27. Of course, some of you guys may recognize already that we're just multiplying each one here by 1/3. So therefore, R is 1/3. Or we could use our ratio. And the ratio just says take one of them, like the 1/9, divide it by the one before it, 1/3. And of course this means to invert and multiply, so multiply that by 3 over 1, and we do get 1/3 for our R. So very easy to do. So what I would like, let's take a look here. Let's determine if the following sequences are geometric. If so, find the common ratio. Now one way to do it, of course, is just to look at, especially with fractions, look at top and bottom. Take a look here. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So it appears that we're multiplying the top by 2. Let's look at the bottom. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So it appears we're multiplying the bottom by 3. So we're multiplying each top and bottom by the same number, so far our R is 2/3. Very easy to do. But notice, what happens to the signs? Positive, negative, positive, negative. They're alternating, so our R here is actually a negative 2/3. And we'll talk more about that in just a few moments. So, let's take a look at 2. Let's see, look here. 1 times 3 is 3, but 3 times 3 is not 5. So the top here is not geometric. So because there's no common ratio, there's no common ratio. Therefore, this is not geometric. It's something else. It could be arithmetic. It could be something that we're not going to disclose in here yet. Okay? So, let's try number 3 here. Number 3. What are we doing? 64 times what is 16? Looks like 1/4. Most of you guys probably know that. Again, times 1/4. Again, times 1/4. So R here is 1/4. But notice again what's happening to the signs. It is alternating. So we make it negative 1/4. So see if you can try number 4. It is geometric, but I want to see if you can find R for that one. It's not too bad to do. Alright, so let's see here. Let's write the few terms of a geometric sequence. Geometric sequence, now in arithmetic we add. So in arithmetic we add. In geometric, we multiply. Or divide. We multiply. So, if we take a look here, and if I tell you that something is geometric, R is 2, that's basically what's called our multiplier. A sub 1, of course, that's our first term. So, my first term is 1. Get my second term, times it by 2, I get 2. Times it by 2 again, we get 4. Times it by 2 again, we get 8. Times it by 2 again, we get 16. And there are 1, 2, 3, 4, 5, comma, dot, dot, dot. And there's our answer. 1, 2, 4, 8, 16. Now remember, because these are, oh look, it's like a little happy cyclops. I'm happy. No, that's a comma. Because remember, in a sequence, we use commas. In a series, we use addition. And we're going to talk more about that again tomorrow. So let's take a look at number 5 here. My first term is negative 3. Multiply it by negative 1. Multiply this one now by negative 1. Negative 1 again. Negative 1 again. How many is that? 1, 2, 3, 4, 5. That's what I wanted. Plus, and then comma, dot, dot, dot. Very easy. So let's try number 6. My first term is 6. This is what I multiply by. I get negative 12. Negative 12 times negative 2 is 24. Negative 48, 96. Comma, dot, dot, dot. Now, what I want you to notice, take note, the negative on the R alternates signs. The negative on the R alternates a sign. Therefore, we call this an arithmetic sequence. Now, if you're going to take BC next year, we deal a lot with arithmetic, alternating sequence. Sorry, not arithmetic. It's called an alternating. Excuse me. Let's make sure we fix that. How weird is that? It's called an alternating sequence. Now, if you're taking BC next year, we spend a long time on alternating series and sequences. Okay, so what I would like you guys to try to do is number 7. Well, let's do number 7. I'll let you guys do number 8. Number 7, my first term is 4. Multiply that by 3x, we get 12x. Now, be very careful. If I multiply 12x by 3x, we're going to get 36x squared. Most people forget the x squared. Do another one. We get 108x cubed, and then multiply that by 3. That's 324, because 3 times 8 is 24, and that 3 is 300. X to the 4th, comma, dot, dot, dot. And there's our answer. So go ahead and try number 8, and we'll go over that in class tomorrow. In the meantime, let's go into the other side here and take a look at numbers 9 and 10 before we go to part 2. All right, number 9. Same thing. This is recursive now. So it's recursive. And again, we want to write the first 5 terms. Now, what's nice about recursive, if you remember, given my first term, this gives me my next term. To get my next term, I'm going to take my first term, my k, and divide it by 3. And what's 81 divided by 3? Or multiply it by 1/3, we get 27. Keep going, multiply it by 1/3, we get 9. Multiply this by 1/3, we get 3. Multiply it by 1/3, we get 1, comma, dot, dot, dot. And next, what they want to do is find R. Well, what is R equal to? 1/3. Okay? And then it asks us to write the formula. So let's take a minute and write the formula for this one. Now, one quick thing for you. If your common ratio is 1/3, this means we must divide. Now, so when I write my general term for this one, we're going to get a sub n equals. Now, what this becomes, and we're going to talk about a shortcut how to do this one later on. I'm starting with 81, and I'm going to divide that. Now, be careful. This is 3 to some power. 3 to the 0. If I divide 81 by 3 to the 0, 1, I get 81. 3 to the first, I get 27. So if I divide like this, 3 to the first, 3 squared. If I take 81 divided by 3 squared, I get 9. So I'm taking 3 and I'm dividing it by some power. To some power. We want it to be 1 on the bottom at first, so I still get my 81, so I take the n minus 1. And in a few examples, we're going to take a look at how we actually write these today. All right, so let's take a look at number 10 here. Let's write out the first 5 terms. It's 5, negative 10. Get my next one, 20. Multiply this by negative 2, negative 40. Multiply by negative 2 again, 80, comma, dot, dot, dot. What's R in this case? Well, I'm multiplying everything by negative 2. Now, one thing we like about recursive formulas, There's r. And if you notice when we did arithmetic, we would add something. It'd be the plus, whatever we're adding to it. So let's get the nth term for this one. Because we are multiplying by -2, we know it's going to be -2 to something because that's our constant multiplication. Now, my first number has to be 5. So this has to go away. So the only way I can make that go away is if that becomes 0. So that's my first term, so I make it n minus 1. So 1 minus 1 is 0, which is going to make this 1. And what do I need to multiply 1 by to make it 5? By 5. And there we have it. There is our nth term. Now, when you go to part 2, geometric series formula, we're actually going to talk about how we get this formula. And we're not going to derive it, but we're going to learn how to use this formula. So you don't have to make them up on the fly like this. All right, so go to part 2, we'll take a look at those.